Bismillahirrahmanirrahim. Now, our topic is the graph of y is equal to cos x. In the previous video, we have discussed the graph of sin x, and now we will see that how we can draw the graph of cos x. So, let's move to the board. Cos x, that is cos of an angle that is equal to adjacent over hypotenuse. So we have to observe the changes in adjacent now. Let's see here in a circle, you know that if we start from this point, from here, then the complete angle of this circle till here, that is 360 degrees. In terms of degrees, that is 360, and in terms of radians, that is 2 pi. So the circle is divided into 4 quadrants. Each quadrant divided in with these red lines, that is 90 degrees. Then I have further divided this quadrant into these angles. These are not lines are not drawn accurately, but approximately this angle is 30 degrees. Then the next line represents 45, and then 60 degrees. Now, keeping in mind that we are going to discuss change in adjacent for cos x, and the other thing that in this circle, wherever we draw a triangle, then hypotenuse does not change. Hypotenuse is same, that is radius of the circle. So if I draw a line from here or this way, then look, when the angle is zero, let me remove this line before that. Angle is 0, then the adjacent, this line is adjacent, and as well as that is radius of the circle. So adjacent and hypotenuse are equal when angle is 0. When angle is 0, then adjacent is equal to hypotenuse. So you can say that when these two are equal, then the ratio becomes 1. So the point on the graph for this point, when angle is 0, on this line you can see these are the angles: 90, 180, 360, 270. So at this point angle is 0. When angle is 0, then adjacent is 1. We have taken the value of adjacent on y-axis and angle on x-axis. So now if I draw that line from 30 degrees, this is 30 degrees. Now this angle is 30 degrees. As angle is increased, this length of adjacent is decreased till here. Now this much is the length. So here at this is approximately 30 degrees, and this is approximately 60, and this is 45. So at 30 degrees, its value is not decreased that much. When angle is 45, this is approximately this much length. When angle is 45, you can see if I draw a line here, at this point. You can see here it is very simple, very easy to understand that if total length is radius, then at the angle of 45 degrees, this length at the angle of 45, this is slightly more than 50 degrees. So this is, if this is the half of this total, then 45 is somewhere over here. Then when angle is 60 degrees, then at 60 degrees, now you can see that this length of adjacent, that is exactly half of this total distance. Total distance is this much, that is radius. This is exactly half of that distance. So at 60 degrees, it will be somewhere over here. So we have considered only these 3 points. So joining all these 3 points, we obtain a smooth curve here. If I remove these points from here, and I will mark these points again on the curve. So this curve will be one quadrant of a circle like this. So at 30 degrees, you can see this is the point at 30 degrees. This is the point at 60 degrees, half, and this is the point at 45. We know we have already discussed the special angles. So in that context, cos 30 degrees, you know, that is, its value is under root 3 over 2, which is in terms of decimals, that is approximately 0.866. So you can see here that at 30 degrees, its value is, if this total is 1, then this value is 0.866. And at 45, this is approximately cos 45, you know, its value is under root 2 over 2. So that is approximately 0.707. And at 30 degrees, cos 60 degrees, 60 degrees, that is 1 upon 2 or 0.5. So this is approximately 0.707. And at 60 degrees, it becomes half. So this is the way we can mark the points. And if we compare it with the circle, then you can see that at 30 degrees, this is 0.866, and at 45 degrees, it is 0.7. This much is, this distance is 0.7. So this is the way we can mark it. And if we come to the opposite side in the second quadrant, at the same height on the other side, if we mark this line, and if I mark line here, then if this angle is 30, this much, this angle is 30, then same 30 degrees will be on the opposite side. But from here, positive angle, that will be 150. So this angle is 150. So whatever is the value at 30 degrees, 0.866, same value will be there at 150 degrees. And on the other side, along with it, you can see that uh, this line from here, this is 45, and at the same height on the other side, this angle will be its reference angle, or you can say basic angle, that will be 45. From here, if we join it, this point with the origin, then this angle here, if I remove this point, this value from here, and now you can see that this much angle, this one, this is 45 on this side. From the other side, from this side, it will be 135 degrees. So whatever the value it has for 45, it is the same value for 135, but one difference you should notice that these values are on the opposite sides. From 0 to 90 degrees, values are this way. From 0 to 90 degrees, the direction of values is this. This adjacent, you can see that adjacent is on right hand side. But for the values more than 90 to 180, 90 to 180, direction of the values is this way. And it is exactly 0 when angle is 90 degrees. So at 180 degrees, it is same value 1. Now you can see that this is 1, same 1 is here, but on the opposite side. That is the only difference, that the value is on the opposite side. So then the curve will move this way to the opposite side for these angles. That is, it will be approximately 120, then 135 and 150. This is 150, which is equal to 30 degrees. Then when we move downwards, if the lines are in this quadrant, now the angle will be from 180 to 270. 180 to 270. Then the value will once again decrease to 0 here. But as it is on the same left hand side, so being on left hand side, it will be negative. Values will remain negative, but the equivalent reference angle will have same magnitude. Length will be same. Now look, if I draw the line parallel to extending this way here, that will be this reference angle, or you can say basic angle, is 30 degrees, and the total angle from here, that will be 210. So 30 degrees onward from 180, that will be 210, then 225, and then 240, and then 270. For these values, it will continue the same curve like this. This will be 270, and once again it will move this way to 260. So this will be the graph. Here the graph is similar type of graph. If we draw the graph with free hand, it will look like this. The main points, what you have to remember, there is 0, 90 degrees, 270, this is 180, and this is 360 degrees. Okay, that is the behavior of graph for one cycle. If there are more cycles like this, then it will be like this is one cycle till 360 degrees. Then next cycle will be here till 720 degrees. Then another cycle we go on adding 360. 360 will be added in it, then this will be 1080, and the next one that will complete here 1440 degrees. So this way the graph continues, and the same thing will be continued on the left hand side this way, minus 360 and minus 720 and so on. Okay, let's see its further behavior on this graphing software. So here I have already written this equation, y is equal to what possible coefficients and constants it can have. I have written all of them. A is for, as we have seen previously, that this is amplitude, and B is frequency, C is horizontal translation, and D is vertical translation. So here at the moment its value of A is 0. You can see here this red line represents a graph of this expression, this complete expression. So when amplitude is 0, this is just a straight line because it makes 0 everything, and its vertical translation is also 0, that's why it is on the horizontal line. Now look, if I change this value, the line will move upward or downwards, but its value on that curve cannot be observed until we change the value of A. Look, this is moving upwards, this is downwards. That means it makes a vertical slide. Okay, how can we see that its amplitude? You can see here like not this one. G. Now A is, let's change the value of A, then you will observe that it will change to a curve. Look, as I increase the value of A, it is changing. For what reason does it change? Because value of A is 4.5, so its amplitude is 4.5 now. You can see here the amplitude is 4.5. If I change this value of C to 0, the same 4.5 is now exactly on this line. But if I change this value of C, if I increase the value, this peak, you can see that it is moving from here onwards this way. It is moving this way. If I go on increasing, it moves forward, and till here, when the next peak reaches here, its value is approximately 6.28, that is 2 pi. 2 pi means one cycle is completed, then the next peak reaches here. If I move it towards left, you can see that next peak reaches here. When I bring it back to 0, the value of C, look at the value of C. Now value of C is 0, its peak is here at 4.5, which is its amplitude. Now B is equal to 1. If I make B 0, this is the coefficient of variable, this angle. If there is no angle, then what will happen? Like you can see that this is simply a straight line at A is equal to 4.5, because cos 0, that becomes 1. Okay, now if I change the value of B, look, this peak and this peak, their difference is 6.28. That means 2 pi. This graph is in terms of radians. So this is 2 pi radians, that is one cycle, and one complete oscillation or one complete cycle of the graph is here in 6.2 radians. If I change it to 2, okay, now you can see that till 6.2 there are 2 cycles, 1 and 2. If I change it to 3, then this is 1, 2 and 3 complete cycles within 6.2. So what does it mean? That this value of B, that actually represents the number of cycles in 2 pi. So in other words, you can see say that this value of B represents that frequency. Now value of C, we have seen that it slides the graph horizontally, horizontal translation, and value of D, that is vertical translation. You can see that as I change the value of D, it moves upwards or downwards, and when it is 0, the mean position is at x-axis, and when I move this way, its mean position is moved upwards, and when I move it towards negative values, its value, you can see that it moves downwards. So this is the way we can understand the graph, and you can yourself practice it on Desmos, that how the behavior of graph is shown here. Okay, then let's come back to the board. Now you have observed all the values. I write the same values here. Y is equal to A cos Bx minus C plus D. This A, what does it represent? Amplitude of the graph. Amplitude. B represents frequency in 360 degrees or 2 pi radians. You can have any unit. This is horizontal translation. Horizontal translation, that is C0, and this is vertical translation, that is 0D. Here you can see that you should realize this thing, that when it is negative sign here, we write it positive over here, and if positive sign is written here, then this will be negative. So these are the things about the graph of y is equal to cos x, and there is only the difference that it is responding to adjacent, change in adjacent. Otherwise, these terms are same as the graph of sin x. Sin x and uh, cos x have same behavior regarding a, b, c, and d. Only the difference is that cos x responds to um, adjacent and sin x responds to opposite. And further, you can see that these are four quadrants. As there are four quadrants, uh, this is first quadrant. 1 and if I okay, this is second quadrant. This is not drawn accurately, so there may be some difference in the values or intervals. So these are four quadrants. Okay, this is first quadrant, this is second quadrant, this is third quadrant between these two lines, and between these two lines this is fourth quadrant. Now from this graph, once again you can observe that cos theta is positive in the first quadrant, and in second and third cos theta is negative, and once again it is positive in fourth quadrant. Here in the first quadrant cos theta is positive, and the reason is that it is towards right, and in second and third quadrant, in these two quadrants, as it moves towards left, so its graph is downwards. Once again in fourth quadrant it moves towards right, so here cos theta is negative. In this quadrant again cos theta is negative. Cos x or cos theta, here cos x once again becomes, let me write it, x. So in the first and fourth quadrant you can observe that cos theta is positive, and in second and third it is negative. So these things you can realize from the graph, as well as in case of sin x. If I very roughly draw this graph till here, this is one quarter, second quarter, third quarter, and these are four quarters. So you can see that in first two quadrants it is above x-axis, and in the remaining two quadrants it is down x-axis, downwards. So here sin x is positive, and here sin x is negative in third and fourth quadrant. Third and fourth quadrant negative, first and second it is positive. So these things you can further understand from the graphs, whatever we have already discussed, the signs of these trigonometric ratios. So that's it. But if you have understood, even then you need to practice different questions to make yourself confident while attempting questions of the paper. So wish you all the best. Allah Hafiz.